Sweet. Here we go. Let me make sure we got everything recording good. Not recording, but streaming. I need to record too. I am my own top fan. I need to figure out how to keep chat up. I don't even know where chat is right now, to be honest. I used to hide it. I'm pretty sure I can put it on. I guess not. I don't know. It's okay. I can just keep my phone open. I need to make sure that this audio source, well, that's okay. If I want to listen to music, I can do it off my phone. Okay. So here is where we're sitting at. We need to redo the track links, I think, for sure. Because it needs to distribute more weight along the track. I'm not sure. This AC is going to drive me insane. It's right on the side of my desk. Okay, we're going to look into this. So what we need to find and we need to look at are motors. So we're going to go into lists. It should be in my saved list. Is that not? We'll find it, don't worry. Eventually. Unless I just have all these jackets and stuff. Did I not save any of the motors? Here it is. 37 millimeters, so that's just over an inch. 200 RPM. Which is the same diameter for all of them. I think I need the angled motor. Same company, by the way. And they come with details. So I can put this inside the undercarriage for the track, run a gear off this to the main drive gear. And then the DC motor on all of these are the same. It's just a different gearbox on them. But I don't know what RPM we want. I don't even think any of the details are different. And they're non-back drivable since they are worm gear motors. So okay, so we're gonna go find a 50 RPM. 15, 225, 35, 65, 50. Found it. Okay, this is our drive motor right here. Plain and simple. Right, so here's what we're gonna do. We're gonna snip this. File, save. 50 RPM drive motor. Now we need a motor to run our hydraulic pump. Which I have no clue what to... I'll probably design the hydraulic pump. We'll see if we can find something now. I mean, it shouldn't be too hard to design. I've designed them before. They're pretty expensive though. I think I'll be able to do like a 50 psi. No, not 50. 500 psi. Here, what's the bore of our cylinders? That's my question. We're doing the 300 P tier. Brochure. I think the pistons are on 4. Nope. Hydraulics. Cylinders. Bore. So it's going to be a relatively 1-inch circle. Okay, actually though, I could make 3 of the exact same cylinders. I mean, the arm bucket, well, the arm one is a little different, but that's it. Oh no, the stroke's over here. Yeah, 56, 65, and 42. That's not gonna work. This is the rod diameter. Okay. But the bore is going to be roughly an inch. So we're going to figure out what the surface area on a 1 inch circle is. And that'll give us how many pounds of force. So below an inch. Sweet. 0.75. So we're going to have 75% of the PSI worth of force on that hydraulic cylinders. So if we have 1,000 PSI, we're going to have 750 pounds of pressure on the back of the cylinder. The front of the cylinder is probably going to be about half that because the rod. So I've been considering switching everything to millimeters instead of inches. Because we'd have to use like M5 and M4 bolts. They're a lot smaller. Let's go to the track. Yeah, because this is the smallest inch bolt I can get. But if I go to metric, I can go all the way down. Well, I can go to an M1.6, but I can go to like an M2. Way smaller. Even this track, I could be using an M4 instead. So I think for all this small stuff, we're going to be switching to millimeters. It would just, I feel like it'd just work out better on that. So here's our motor. How tall is it? 70 millimeters. .75. We might be able to use the same motor for our gear pump. I want to use a brushless. I want to use just a brushless DC motor and gear it down instead because the worm gears are more inefficient. I would like to even like use a brushless motor for the tracks too, but I don't think that's going to work very well. Unless we use a cylindrical gearbox, which is non-back drivable. But I'm not a huge fan of using worm gears to run stuff. It would just use more electricity to do something that we could do for less. I mean, it would work just fine, I'm sure. But we could do it better. But I don't think they have small enough. Yeah, all these are the same size. All these straight ones share the same motor, just a different gearbox All these worm gears share the same motor, just a different gearbox. I think these two big ones share the same motor. These are just N20s, which I might be able to use for the hydraulic. No, I'd use a servo for the hydraulic valves or solenoids. I don't know if I want to just make an array of solenoids to control the hydraulics or actually make a hydraulic control block. That's a consideration. Let's see if we can find any other motors alike. You'd need a motor controller for this one. Wonder what brand's behind that. We're about to find out. Flash Hobby. Oh, yes. Okay. Motors. Which ones are bigger? We're going to find out. So these are D series. I'm pretty sure these are for drones, but yeah, these are definitely drone motors. It's kind of funny to me. Yeah, let's not use that for our hydraulic systems. Oh, that's turned up. That's not good. That's probably just gonna... Oh boy. What else can we find? I like that. Those are kind of expensive per motor. I wonder if our... I don't know how to... Garrison, something like that. I wonder if our previous motors, if they used a planetary gearbox or what kind of gearbox they use. I don't think it's going to tell us though on these straight ones. Yeah, just gear motor. Perfect. Yeah, gear motor. I feel like I might have been able to figure that part out. Can drive 15 kilograms in what setup? I don't want to have to take one of these and try and mount it in the other undercarriage, because I don't have a good script for bevel gears and on shape at all. So that's something I don't want to mess around with unless I use like 45-degree helical gears. Okay. The other thing about these motors is I don't really seem to see one small enough that I would like to use for... My brain keeps stop working. For my turntable. I feel like this is not the product dimensions. Okay, let's go up to this. 20, 33, plus L. Okay, what is L on this one? I know the motor itself is pretty much 1.5 by 1.5. I can't fit that sideways on the undercarriage. We're thinking hard. We're thinking real hard. We're just gonna look up RC motors. This might be a good motor for the hydraulic pump. The other one would work just fine too, because it's a nice geared motor. I could just hook it directly to the pump. I don't know. I think we might be able to use basically any motor for our turntable as long as it's not absolutely tiny. I'm not used to this RC motor market. What RPM is this? High speed waterproof, sweet. Shaft 540 motor. Sorry, 4-pole? Interesting. Hey, I could always design my own if I really wanted to. I'm considering it. Because you can never find a motor that is like the one you want to use. If I can design a 2-inch diameter axial flux 3-pole motor and geared down a good amount, I'd be really happy with that. And run cycloidal gearbox inside of the hub. Possibly. I can envision this whole thing, but I just can't reach out and grab it yet. Whoa, what company is this? Oh, good lord. They are all about RC stuff. Apex products. Let's see. By VRC. Oh, that's also 550. 550. Probably another 550. Yep. 27 turn. So that's not... Or is that 27 windings? Don't know. No idea. Okay, anyways, this needs redesigned. I definitely think this needs redesigned. I think we need to switch everything to millimeters. It's gonna mess everything up. We're basically gonna have to start over. So I kinda don't want to do it. Or should we just do everything in inches and use metric bolts? I mean, that's a way to do it. It's kind of a rigged way to do it, but it's a way. I'm thinking about going to motor drive actuators too, instead of hydraulic. I think doing the hydraulic thing would be pretty cool. First time doing it, just send it. Go big or go home. Thing that like boggles my mind with this undercarriage is first I need to make this idler wheel, the frame for it, but I don't know how tall that or how much I need to offset that frame up to get to the actual main frame, because I need room for the idler gears on the bottom. So I kind of need to make these idler gears, all the not gears, rollers. I kind of need to make all the rollers which means I need to remake the chain. And we're going to make our lives really easy and just do this. Now we don't got to worry about the old chain anymore, and we can just remake it and go on our way. That needs switched around. Reference needs brought over here. We'll do a folder called basic. And put these two in. Leave all our reference stuff out. This can swing from here to here. So that's getting its max reach. This can swing from about there to there. That's getting its max reach. That's kind of, this one's kind of difficult to think about, but I reckon this one will go about down to here. The arm will be there, fully laying down basically. As long as you can get this point on the ground, that's about how far down that needs to go. So I guess we'll set it up like that. When we put that hole through for that hydraulic and figure out where to mount it. How much of this can I really 3D print though? Is the next question. .2. Those idle rollers are pretty big. It is a pretty big chain though too. Good Lord. Okay, we're gonna go back and that's basic. Now we need to be in a new studio. Not in basic, please. Select this document thumbnail. Nice, that's cool. I'm pretty sure I can just take this out like that. No? Move to parent folder. There we go. Okay, back to the chain. So we want we'll do about a 1/2 inch for the gear. And then we'll start on either side and do how much is that? That's 6 millimeters. Okay, we'll do a 1/4 inch thick on that. So we'll just do a 0.5 by 0.5 like that. That's not gonna. Come on. There we go. So we'll do 0.625. I have no clue what our pitch is going to be yet. We'll do 0.5. And we'll do that. That. Make these equal. .25. So 1/4 inch on that. And we need to do a chamfer before that sketch, so that we can make that. And now it tells us how far over we can put this without anything hitting the centerpiece. So what is our pitch? 1.25. I think that'll be all right. So we'll just do a symmetric remove like that. And then I can actually bring that out. I don't know why. Okay, let's just do this. We'll do 4 millimeters. And then now we need a 4 millimeter nut. So we need what do I need? Assembly. M4. Insert. .276. We could put the nut on the track. I'm thinking really hard right now. I think that we don't need We don't need to be able to change out. Do we even need to be able to change out our track plates? Or can we just change that link out? Because, I mean, it's an RC. You can just pull it off. I mean, it'd kind of be a pain, but if I run the nut on the top, you'd have to take the track off anyway. So I'd have to run the nut on the bottom. But I don't have any M4 bolts for when we're test printing this, so I will have to make some placeholders. 0.2775 will do. How tall is it? Sweet, we'll do 0.1. Sounds good to me. We kind of need to make this solid. Come on. Come on, do what I want you to. 0.1, and then we need an M4 hole. If I can find the center. It's not going to let me. 4, we'll do 4.25, so we have some leeway on that. I don't want to have to thread the bolts into the plastic just to get it to go down to the bolt. Okay. There's that. Now we're going to take and I think I did 0.5. I'm going to make a spacer, 0.375, to go between these. As a roller on every single one of those. So that these don't try and rotate in or out at all. Because it's going to be a lot of slop in the system if it does that. Now we just need to... That's not centered. What? Did I not make that 0.5? Oh boy, it's going to be a long day. Can't even type. Okay. We need the center of that, so we need to take a plane off this out of 1/4 inch. We need to get in this plane. And we're going to look at a track. We're going to search up a picture of a track real quick. Don't care about that motor. Just want that one. I said excavator track, not skid steer track. Come on. Well, I at least want a big excavator track, not those tiny ones. That track looks healthy. What brand is this? I'm confused. I've never seen this brand before. That looks like a case dozer. That 100% looks like a case dozer. That's just a case dozer. What is this excavator, though? I mean, it shows it just in a... like a training sim, but... yeah. That's probably just a training sim. Simulators, yeah. Nice. Cool. I thought that was an actual equipment brand I've never heard of before. I got so confused. See, this one's got 3 plates. Oh, some of the other ones have 1 plate on it. I mean, they got four bolts on it, though. We only have 1 bolt. So I can't do a 3 plate. I'd have to do a 2 plate. I mean, it's 1 plate, but like ridge-wise. Hmm. I have no clue how many links I even need. We'll figure it out as we go. If I need to shorten up the link a little bit, I can. Oh, this is a great picture. Okay, I think we're going to do two ridge. But we're definitely saving this picture. Oh, no, I'm saving the wrong one, but it's okay. I'm definitely saving the wrong one. This one. It's only got 2 bolts, too. No, it's got 4. You just can't see the other one. Yeah, I like this one. Sweet. We need to pull that into our... yeah, you're going over here. Yeah, so even if you're on carpet, because these chamfers, it won't catch on the carpet. I'm not going to do the cup design, how it's not straight. I think this, no, this one's kind of cupped that way too. I think they're both the same. But they're not straight. Mine are going to be straight. But I do need, like, it chamfered up to it, like it is. Just because I don't want to strain the plastic too much. So I'll stop that early. I'll come up and over and up and have a ridge. And over here. And have a ridge. We need a point in the middle of the circle. We're just going to do this. Yes, it worked. Thank God. Okay. So I need that. And I need that. These ridges can be 0.1. This can be 0.1. Come on, that's not what I wanted. Come on, come on. 0.05. What part of this is not locked down? Okay, the entire thing. Sweet, problem solved. That and that. Point 1. We're going to try and make this 0.3. Is that too much? Maybe. But we need this further. Okay, we're going to do this. Symmetric 4.75. I hope that didn't add to that one. Okay. I'm going to chop that, that, and that. And that. Okay, I reckon those ridges can be taller. Because that bolt's going to be pretty tall, and I don't want the bolt to be the main traction point of the entire thing. Oh, 4.25 millimeters. Or 0.25 millimeters. We're going to draw a line. We're going to get the center point, and we're going to hook the center point to the origin. What? Oh, I guess that's right. We might have to make those ridges taller again. Okay, I think that's where it's going to be now. Sweet, I think when we're testing this, I might print it as a single piece. Maybe. We'll see. We haven't got to the test print yet. Let's get this mirrored over. That looks good. I like that. Okay, let's put it together in the assembly. Make sure everything's right. If it's not right, we're going to have some issues. Current 2. There's the left one. There's the right one. There's the spacer. There's the track. Okay. Spacer. Spacer. Track. Insert. Standard. Sweet. Everything's lining up so far. I'm pretty happy. That's 0.6. What's 0.6 in millimeters? $15.2. Alright, that's already on 15. Insert. Oh, those are like the perfect height. Oh, boy. It's all coming together. This one, I'm a lot happier with this one over the last one. Okay, let's get all of this. And then we'll get these appearance. I like the gold. Leave me and my gold alone. Let's get these head in. It's gonna give me a headache. Paste, paste, paste. We're going to do some test rotating. This should be a 0.05-inch gap right here. Yep. Wow, this came together good. I like this. We're going to fix that one. We're going to grab this one over here. Let's see, we can go... Oh, see, this is why we test it. Because that track is inside of that link. Other than that, would be solid. I can't just make that rounded off completely because it won't print very well. And we need it to print well. We could probably, I mean, we can cut out of that track right there. Out of the front of the track right there. I'm okay with that. Front of the track. 0.275 just to get some clearance on it, and we'll just do 0.3 on that. Square that up at that. That's about halfway on it. Get that and that. Remove, remove, merge this one, face that. And then we're going to mirror feature that on the right plane, reapply it, okay, that problem is solved. And it is just enough. Yeah, this track can actually turn back kind of on itself a little bit. I wish I knew what degree this was. This should be our first. This one. 10 degrees that it can turn back on itself. And then these can all... What's the distance on that? 4. Yeah, it's going to be tighter than that. It's going to be really tight going around the drive gear. That's 3. Oh boy. We have a really long pitch chain. Because I think... What's our drive gear? Okay, it's 4.5 inches in diameter. Okay, we're good. That's better. I was getting worried for a second. Yeah, we can open this up some. That looks good. That's okay. I'm okay with that. Okay, we are going to make some inserts for that. And then we're going to do a pin with a snap ring around it, fully 3D printed. So I can print maybe 3 of these, 3 or 4 of these, put it together and see how it is. And we also need a pin with a snap ring to go through here too. So 2 pins and snap rings, and an insert for that hex. Or I can just do a spacer. I don't know. We'll figure it out. We'll get it. Or I can just edit. Yeah, we'll probably just edit it out. Okay, we're going to mirror both of these up above the part. New. Add. What's this, 0.1? Yep. Okay, there's those. So we're going to name this one left. I know they're swapped this way, but you'd be looking at it from the other way. Really, it doesn't matter. I just need to distinguish between the two. We're going to do this TP for track plate, SP for spacer. Come on. Here we go. Number 1 is that one. Number 4 is that one. Time to make the pins. So we're going to hide these two. We're going to make this first pin 0.25. We're going to go up 0.05. Nil. I have not had any success with a 4mm pen. Normally, a 4mm pen will just not print correctly. So we are going to start praying or something. Offset by 0.025 in that direction. Is it the same color, so it's the same part? Yep. We're going to sketch, offset, we'll do 0.0125. I know it's just really small measurement, but no. There. And then sure. Yeah. And then we'll go up, back out to 4mm. I don't even know if that pen is going to print correctly. That's going to be way too long for the roller. But I just need to get the track together. What would this be, a 6mm pen? About. This is the size of pen that I have had success with. Can we just hide that? Get that out of the way. New. Where's the center? Here it is. We'll try 6mm, see where it sits. Looks good. A little track play is okay for now. Offset distance by 0.025 towards us. Offset this other way, down 0.0125. Bring this out by 0.05. Back to 6mm. also had some success with just cutting a slot in the middle and making these snap in. I've had my most amount of success with that. How much do I really want this to have to bend to snap around that is the next question. I did absolutely 0 measurements there. It should be okay. We'll see. 0.04. New. 0.01. As long as this point is smaller than that point, we're good. Should be. Now I need to do this one. Get our square on here. Right there. There. So, we'll take all of this. Small pen. Oh, that's the same as up there. Snap ring, large. Snap ring, small. Even though I could do 4mm and 6mm, but that's just boring, I guess. Okay, take this, take that, this. Export. Export parts as individual files. Track. Export. We're going to open up where is it? Is it over here? I'll do the slicer. Good into Elegoo. Get these. I need to go turn the printer on so I can just send it to it. Oh, come on, Elegoo slicer. Oh, it's opening. Okay, we're good. Oh, there we go. Downloads, track. We need to unpack this. straight into downloads. Nice. Take all of these. Oh boy. Um Please tell me these are no. One of these did not export in millimeters. Okay, so I need this to audio. Most of these will auto-orientate correctly. Where? Okay, back to Onshape for just a second. We're going to export these one at a time. That was right. Okay, left. That was right. Okay, we're good. We're good. All good. Right and left. No. Is there a button where I can just click and drag? Okay, we're gonna auto arrange. I'm gonna copy all that. Come down here. Alright. Sweet. We're gonna slice this. This is probably gonna take long enough. Total print time an hour. You're funny. Good jokes. We're not doing an hour. Oh yeah, no support. That's always good. If you can make something where you don't need support, it's a good day. Infill 5%. Top layers 4. Bottom 2. How many walls? Where's my walls? 2? Okay. I'm okay with that. Still an hour. Absolutely no difference made. Okay. I'll make a time lapse for you guys. My chair just fell over. Had to put the lid on. The PLA enjoys the higher stable temperatures. When the heat and AC turns on, it fluctuates the outside temperature too much, so we're just gonna let the chamber do that stuff. I don't think the Elegoo Neptune has chamber temperature regulation, but I'm just going to let it stay the same. Anyways, now that that's printing, I'm probably going to have to start the stream on my phone to get the results of that. I'm kind of bored now. I think I need to go watch some YouTube. A YouTuber watches YouTube. Imagine. Crazy. My phone fell. Whoops. Well, I'm going to go ahead and get off the stream. Have a good day, everybody.